This is example 7.6 from Discovering Design with Chemistry. Iron can be produced from iron ore, Fe2O3, according to the following equation. Suppose a chemist wants to make 100.0 moles of iron. How many moles of Fe2O3 will he need? How many moles of carbon will he need? How many moles of CO, or carbon monoxide, I think, will be made? All right, so he wants to make, and it's not writing. He wants to make 100 moles of this. That's right here. So we could go ahead and fill in 100.0 moles. Okay, I gotta get the pen to work. That looks terrible. And so we don't have to know the limiting reactant for this one because we know how much we want, and so we want to make sure that the others produce, that we start with the amount we need in moles of each of the other ones so that we produce the amount that we want of this one. You might be able to quickly be able to do this just by recognizing that if you end up with 2 moles, you need to start with 1 mole of this and 3 moles of this, and you could probably just kind of do this in your head, having or tripling that 100, but we're still going to work through it in the same way because when we start doing stuff with grams soon, this will be helpful to understand how to convert things. So 1 mole of Fe2O3 goes with 2 moles of Fe, and then 3 moles of carbon goes with 2 moles of Fe, and of course these only apply to this one problem. And the last one is 2 moles Fe goes with 3 moles of CO. And notice that all 3 of these had the same Fe in the thing, because that's the amount they gave us, was that it was 100.0 moles of that. So everything else is going to be figured out by starting with that 100 moles. So let's do this one first. So we have 100 moles of Fe, and we want to get, oh wow, that was terrible. We want to get rid of the Fe, and we want to get Fe2O3. So we're going to use this first one up here. So 1 mole of this one goes with 2 moles of that one. So our moles of Fe cancel out. And it's basically just 100.0 divided by 2. You can do 100 divided by 2 in your head, but you have to pay attention that there are 4 significant digits in the 100, and so your answer, you know it's going to be 50, but it needs to have 4 significant digits. You can also use a calculator if your brain's just working so hard to keep straight these different relationships and to make sure that you've got it right. You can use a calculator even for the little easy division ones. All right, the next one we're going to do, we want how many moles of carbon will he need. So again, we're going to start with the one that they gave us, the given one. And this time, in our conversion relationship, clearly I am struggling with drawing a straight line today. Sorry, guys. So we're going to get rid of our moles of Fe and trade them out for moles of carbon. And so we're going to use the conversion relationship for that one. So the 3 goes with a C, and the 2 goes with the Fe. Our moles of iron cancel out, and this time we have 100 times 3 over 2, which you probably can see that's 1.5. 3 over 2 is 1.5. 1.5 times 100. So you may be able to do it in your head and realize it's 150. If not, it's totally fine to use a calculator. The important part is remembering that we still need 4 significant digits, so it's going to be 150.0, and that's how many moles of carbon that he needs. And then the last one is we want to know how many moles of CO will be made. So again, we're starting with what we know, what we were given, and then we're going to use our conversion relationship to replace our moles of Fe with moles of CO. So that means we use this last conversion relationship. The 2 goes here, and the 3 goes here. All right, in this case, this is actually exactly the same as the last one because we've got a 3 on top and a 2 on bottom, and so if you recognize that, you don't even have to pull out your calculator or think about the answer in your head. You're going to get the same answer. So if we want to make 100.0 moles of Fe, we need 50 moles of Fe2O3 and 150 moles of C. And in addition to that making 100 moles of Fe, it also is going to make 150 moles of CO. All right, the next problems are going to get a little trickier. We're going to start mixing in grams, so make sure you can do these before we move on.